students. In the previous lecture, we learnt about uniform motion, non-uniform motion, uniformly accelerated motion and non-uniformly accelerated motion with some numericals of acceleration. Today we will learn about acceleration due to gravity. Gravity is the force with which Earth pulls an object towards its center. Remember, Earth pulls an object towards its center, not the surface. Now, whenever a body is pulled towards the center of Earth, due to this pull, its speed continuously increases. And usually, when a body is dropped from certain height, it follows a straight line path with an increasing speed. Now, this increase in speed is because of gravity. So that is why this acceleration is known as acceleration due to gravity. The value of acceleration due to gravity is approximately 9.8 meter per second square. Sometimes we take the rounded off value also as 10 meter per second square. When a body falls down under the influence of gravity, its speed goes on increasing. Hence, this G accelerates the body. Whereas, when a body is thrown up, here, since G is pulling it down and the motion of the body is upwards, so here G retards the body. And here G accelerates the body. So, while solving the numericals, there are two ways of solving the numericals. I suggest you for 9th standard, you follow the way where we assume G accelerating in downward direction and G retarding in upward direction. The other way is according to the sign conventions. In sign conventions, if the observer is standing at the ground and ground is taken at the origin, then all the directions upward are taken positive, all the downward directions are taken negative. So if we take this convention in our regard, then in that case G will be negative in all the cases whether the object is going upward or downward. But in that case, we will have to take another sign conventions also in consideration. That is, if the body is thrown upward, the velocity will be positive because upward is positive. If the body is dropped down, then the velocities will be negative because the body is coming downward. So, better not to get into this vector convention, but coming to this part, it will be easier for you to solve numericals in 9th grade. Just a repetition, when a body comes down, G accelerates the body, and when a body is thrown up, G retards the body. Let us see an example. A body is dropped from certain height. Find its velocity at t equal to 0, t equal to 1 second, t equal to 2 seconds and t equal to 4 seconds. These times are from the time of start of the fall of the body. Suppose this is the body which I am dropping. Right now when I am holding it in my hand, it is at rest. It means that initial velocity of the body is 0. When I drop it down, its velocity goes on increasing and we have to find out that what will be its velocity after 1, 2, 3 and 4 seconds and so on. So we can clearly see, directly write down for the first situation that velocity at t equal to 0 is 0. If I write down these values in a tabulated form, then at t equal to 0, the velocity is 0. Now, let us see what will be the velocity at t equal to 1 second. At t equal to 1 seconds, using the formula of acceleration, a is equal to v minus u upon t. For downward motion, we take the value of a as 10 meter per second square with a positive sign because it is accelerating. So, 10 meter per second square multiplied by time goes on this side. This will be 1 second is equal to v minus u. U means the initial velocity from where it started. This will be 0 here. So this gives us v is equal to 10 meter per second. This is for time 1 second. So if I write time 1 second here, the velocity will be 10 meter per second. Then for t equal to 2 seconds, the formula remains same. A is equal to V minus U upon T, and we get AT is equal to V minus U, which means that 10 meter per second square multiplied by 2 seconds is equal to V, which is equal to 20 meter per second. So at t equal to 2 seconds we get 20. Likewise, if you solve it for 3 seconds and 4 seconds, you will get the values as 30 and 40, which means that the object is gaining a speed of 10 meter per second in every second. That is why we say that gravity is uniform acceleration. Gravity is producing uniform acceleration in a body. Another example, I have taken a body which is thrown vertically upwards, which is with a velocity of 40 meter per second. किसी ऑब्जेक्ट को ऊपर की तरफ 40 मीटर पर सेकंड से फेंका गया है. Find its velocity at t equal to 1 second, 2 second, 3 second and 4 second. Here in this question, when the body is just thrown, that is the time where we have started our observation. So it means that at t equal to 0, its velocity is 40 meter per second. So if we write down in this table, at t equal to 0, the velocity has its value of 40, and this is what we call initial velocity also. So for t equal to 1 seconds, when we have to find out the velocity, we will use the value of initial velocity to be 40 meter per second and acceleration as minus 10 meter per second square, because in upward direction I told you that g is retarding, and retardation is taken with a negative sign. So using the formula A is equal to V minus U upon T, we get AT is equal to V minus U, or V is equal to U plus AT, which gives us V is equal to 40 minus 10 multiplied by 1 in meter per second, which is equal to 30 meter per second, which means that after 1 second, velocity of the body becomes 30. Likewise, for t equal to 2 seconds, we have to find out the velocity. Initial velocity is still the same from where the motion just began, and putting the values here in this formula, we get V is equal to 40 meter per second minus 10 meter per second square multiplied by 2 seconds. This gives us 40 minus 20, which is equal to 20 meter per second. So after 2 seconds, the velocity becomes 20, and if you keep on solving it for different times, you get at 3 seconds the velocity will be 10, and at 4 seconds the velocity will become 0. From this example, you should also understand that at 4 seconds, when the velocity becomes 0, it means that the object must have attained the highest point of its flight, and now it will start coming down under the effect of gravity. So the highest point velocity becomes 0 whenever an object is thrown upward.